Today I'm going to introduce you to the most basic rational function. A rational function is a ratio of two functions, so we end up with some variables in the denominator. Specifically, it's the ratio of two polynomials, so we can think of one as the very most simple polynomial, it's x to the 0 polynomial, and this is an x to the first polynomial. You're going to see things that actually look more like polynomials when we get into more complicated versions of this. But let's just start out with the basic characteristics of a rational function. First of all, since there are variables in the denominator, that means there are certain values of x that will make y undefined. So, for example, if I put 0 in for x, y would be undefined. That means I cannot plot a point for x when x is 0. So notice that the whole y-axis, that would be where x equals 0, has no points on it. It's absolutely impossible to have a point on that. We would draw a vertical asymptote there, and vertical asymptotes cannot be crossed. Thou shalt not pass. You cannot cross a vertical asymptote because a vertical asymptote is saying nothing exists there. There is no y value for that x value. Very important. Now, what happens if x gets close to 0? You know, not exactly 0, but close to 0. So let's make this 0.001, for example. Well, notice now y is 1,000. Y is getting really, really, really big. And you can see that the graph going up and up and up as it gets closer to the y-axis. Now, what if we made this a negative number? Negative. So if x is a negative value close to 0, the graph is going down and down and down and getting a very large negative number. And we'll notice here that if we keep adding some zeros in here, notice that y keeps getting bigger and bigger, but in the negative direction. Or if this were a positive number, y would get bigger and bigger, but in the positive direction. So what we say is that as x approaches 0, y approaches positive or negative infinity. And now what happens if x gets really, really big? Okay, so let's make x bigger and bigger. So let's put in a pretty big number. Let's do 1,000, okay? Well, y, oh, that's 100. Y is just 0.001. So when x is getting really, really big, so imagine it going off to the right, y is getting closer and closer to the x-axis, to 0. So if we kept adding zeros here, we can see that y is getting smaller and smaller. Okay, so if I can spread this out, I don't know if actually pulling this over will give me more zeros. No, it's just going to go ahead and go to scientific notation. But anyway, y is getting, so as x gets really big, y gets close to 0. So that is another asymptote. We have a horizontal asymptote. And what's interesting about our horizontal asymptote, our vertical asymptote is a wall that says thou shalt not pass. But the horizontal asymptote is actually telling us what happens to the graph if I would to zoom way out. What would that graph end up looking like? Well, basically the graph ends up looking like a horizontal line. Just in the middle we have where the asymptote is, but basically the graph is the horizontal line. So let's zoom back in. Okay, so that's the most basic of the rational function. So let's do a little playing around. What happens if I were to subtract 2 from x? Notice the whole graph shifted over to the right. Now instead of my undefined value occurring when x is 0, now my undefined value occurs when x is 2. When x is 2, y cannot exist. If I substitute 2 in for x, I get an undefined value for y. So there's my new vertical asymptote. What if I add 1 to the function? Now the whole graph is shifted up 1. So what happens when I make y really, really big? Before, when I made y really big, x really, really big, y got close to 0. Now let me make x really, really big. Oh, y is getting close to 1. If I made this 3 instead, look at this. As x gets really, really big, now y is getting close to, as x gets really, really big, y is getting close to 3. So this number up here tells me as x gets really, really big, this fraction is getting very, very small, close to 0, so y is getting close to 3. So the number that I subtract from x tells me my vertical asymptote, and the number I add outside the function tells me my horizontal asymptote. One more thing to show you. So let's go back to my original. What if now I multiplied the entire fraction by a constant? So let's say I multiplied it by 2. Okay, so notice instead of going through the point 1, 1, now it goes to the point 1, 2. Or if I multiplied it by negative 3. So now instead of going through the point 1, 1, it goes to the point 1, negative 3. So it flipped upside down. The graph reflected across the x-axis. Now, the way I wrote this is one way to write it, but another way to write it, let's remove this parentheses here, is, oops, that's not what I meant to do. I want the x down here. Here we go. I just want to get rid of my parentheses. There we go, don't need my parentheses. I can just change the numerator, because when I multiply by a constant, I multiply and say by 3, that would be 3 over 1. That would just make my numerator 3. Or if I want to do my negative 2, okay,